will be discussed in unit 3, right? So unit 3 is about completely normalization. So I want one of you to talk about normalization. Why do we go for normalization, right? So what are the advantages of normalization and so on? Nitin Gupta. Nitin. Nitin. Right. Hemant. Hemant.
Yes, sir.
Hemant. Go for normalization. So what is the use of normalization in a DBMS?
Yes, sir. So basically, normalization is splitting a database table into smaller tables. So why we go for normalization is basically to avoid redundant information. And another advantage is that if we want to insert some kind of input information, say we have a table that consists of the details of departments and faculties together, and if you want to insert a new record about a department without any faculty, then we may not be able to do so in the existing original table. But if we split it into two tables, basically separate table of department and faculty, then we may insert a new department without having any faculty also. So this kind of inability to add any input information can be avoided.
Right. So good. Right. So we have 2 points about normalization. As you rightly said that to avoid redundancy in data storage, we go for a normalization. So to avoid repetition of information, to avoid redundancy in a relation, we go for normalization. Again, to put in a different way, to avoid the different types of anomalies associated with a database, we go for normalization. So there are different anomalies like insert anomaly, delete anomaly, and update anomaly that exist in a database. And to avoid the different types of anomalies in a relation or in a database, we go for normalization. Right. So normalization is basically a schema refinement process, right? So schema refinement process means we are going to break a complex relation into smaller relations, right? So that there is no redundancy in data storage, right? So there is no redundancy in data storage, and you will be able to avoid the different types of anomalies, right? So you discuss something about insert anomaly, right? So you have a department table and a student table together, right? So it is not possible to have a department with no students registered for the particular department, right? So for example, our institute plans to start some new department like artificial intelligence and data science, right? So we cannot have the information about the department alone in the relation. We need to have some values for the students, then only you will be able to have it when you have both the student and department details put together. Whereas if you have a separate table for department and separate relation for a student, it is possible to add a department details, a new department details, even if no student has registered for the particular department or for the particular course. So that's known as insertion anomaly, right? Again, we have something called update anomaly. So for example, you are going to store student details and department details together in a table, right? So you have student ID, student name, maybe age of the student, address, department ID, department name, and location. Finally you have contact number of the department. Fine morning, if the department contact number changes, right? What will happen? I have to update all the records. I have to update the contact number, department contact number in all the records that is present in the student department relation. So even if one record is missed, it leads to data inconsistency, right? So you have around 70 students in your class, I'm going to update the contact information of the department for all the 70 students, and somehow I missed one record. What happens is that it leads to data inconsistency, since you have multiple copies of the same data that do not agree, right? So that's known as update anomalies. So it's very difficult to update all the records in a relation. Rather than you are going to have student details separately and department details separately, I can update the department phone number or contact number only in the department relation, right? So I need not update it in all the relation. So again, the third thing is like a deletion anomaly, right? So for example, a student would have been registered for a student is associated with a department, right? So what happens if student completes the course and leaves the department, right? So if all the students of a particular department, they complete the course and they leave the department, and we are going to remove the student details, ultimately the department details also gets deleted. So what happens is that in the case of deletion anomaly, right? So the details about the departments, they are being lost once we are once all the students of a particular department leaves the particular department. So we have some department which is not popular, right? Let us assume that you have a department, a specialized department which is not popular on job prospects. So what happens is that only few students have registered or associated, they are being associated with the department. And once all the student leaves the particular department, then the department information is lost. We are going to remove the student details, and since student and department details are present together, we are going to remove the details of the student, and in turn it removes the details of the department also. So the entire information about the department is lost once all the students who are associated with the particular department completes the course and leaves the department. Whereas in the case of uh, if you have a schema refinement, you have student schema separately and department schema separately. So the department continues to exist even if there is no student who is enrolled in that particular department, right? So these are the different types of anomalies. We call it as insertion anomaly, deletion anomaly, and update anomaly. So we'll discuss more about this anomalies and data redundancy in unit 3. Unit 3 is about normalization. We'll study how to perform to check whether whenever you go for schema refinement, we need to check whether it's a lossless decomposition and dependency preserving decomposition, right? So whenever you decompose a complex relation into smaller relations, you need to ensure that there is a lossless join decomposition of the relations, and right and dependency that exists between the variables should be retained in the fragmented tables. So for example, there exists some dependency between a roll number and name, roll number and department, right? So the same dependency should exist in the fragmented tables. So decomposition is said to be lossless decomposition if the natural join of the decomposed relations gives you back the original relation, as well as the dependency is preserved between the attributes in a relation. Right. So next we discussed something about the functions of a database administrator in the last class, right? So can someone enumerate the functions of a database administrator? Right. So I want someone to come forward and say about the functionalities of a database administrator.
Giving rights, backup and recovery operations.
Right. Tell me. So performing backup and recovery operations on regular basis, granting access rights to
Different users.
different users.
Yeah, different views to different users.
Right. Then
maintaining the schema of database for better memory usage.
right. So right. Then
monitoring performance of the system.
right. So that's the important task. Like one user or one program running should not consume all the resources, right? So you need to ensure that the workload is distributed evenly among all the users. The resources are distributed uniformly among all the users, right? Next. Right. So
Managing the security aspects of the database.
Right. Right. So the primary job is to define the schema, right, and granting user access rights to different users, creating users, right, creating some database users, and granting different access rights to different types of users, performing regular backup and recovery operations, right? So every day you need to have a backup of the changes that have been done to the database, either in a magnetic disk or tape, right? Uh, uh, they also perform some routine maintenance activities, and again, right, you need to ensure that the work is balanced. The work is the users are being balanced access to the resources in a particular system, right? So these are the major task of a database administrator. So in today's class, we'll study about two-tier and three-tier architecture of a database system, right? So like a previous class one, we also discussed about the structure of a database system. So in today's class, it's about two-tier architecture and three-tier architecture of a database system, and we'll also study something about data mining. Right. So in lab, basically we'll be working with both two-tier architecture and three-tier architecture in a database system. So you are familiar with the database system structure, right? So you have the storage manager components, then you have the query processor components, and the different types of users who are interacting with the system. Right.